Hello and welcome to Empowered Learning. This video will show you how to make a modified box plot on your TI-83 or 84 calculator so that you can look at the interquartile ranges as well as identify what outliers you have for a set of data. So let's go ahead and get started. So the first thing that we want to do is take this data set that we see above and enter it into our calculator. So to do that, we need to go to the Stat area and then go to Edit. And as you see here, I already have this list in here. But to demonstrate how this is done, I'll go over to the column L2, which is List 2, and type in a few numbers to show you how this works. So once we're here, we just go to our numbers here, click 40, hit Enter, and then after that, 5-1, hit Enter, 3-6, then Enter, and we just keep on going until we list all 20 of these numbers. And so please be careful to make sure that you double check whenever you type these in, as you may have some typos and that might skew your data some. All right, so let's go ahead and clear this. All right, so now that we're done with that, the next thing that we want to do is check our window, okay? And so when we check our window, we want to make sure that we have values for the X-min and X-max that are going to match up. As you see here, I have a data value for X-min being 0 and a window value for X-max being 60. The X-min is the minimum X value I would like to see, and the maximum is the largest. And in this case, since we just have just one set of data here, meaning that all these are going to be representing X values, it sort of makes sense to do this. If you notice here, the smallest data number that I have here is 15. And the largest that I have, it looks like it's 56. So I've given myself some room on the lower end to go all the way to 0, and on the higher end, giving myself a little room there and get to 60. For the Y-min and Y-max, I suggest that you put the Y-min at 0, and the Y-max you could have it be, as high or low as you want. But normally I wouldn't put this number here too high, because you don't. You want to actually be able to see what's being plotted. So I normally leave this from 0 to 10, and it normally does great for me. All right, so now that we have entered in all of our data and we've checked our window, the next thing that we need to do is to tell this particular calculator to actually do a plot of our data here, and we want to do it on a modified box plot. So to do that, we need to hit the second button and then the Y equals, because you see above it, it says stat plot. And we're just going to choose 1 here, and we want to cut this on, so we'll just hit enter there. And if you notice, as I come down here, this is a regular scatter plot, linear plot, histogram, and right here is your traditional box plot. Okay, and so with the traditional box plot, what it does is it will graph for you what your minimum number is for your data, your maximum number, as well as your median, which is your middle number, and your interquartile numbers as well. For the modified box plot, which is what I have selected here, so how I get there is I just keep on clicking until I get to this point. What that's going to do is it's going to plot all of my data values, same thing, the median, interquartile ranges, and all of that. But the one thing that it does not do, it will not plot any outliers within the normal box plot area. And so what it does alternatively, and if you can see here, this thing is clicking, If you look, those two dots that you see on the end there, those dots are representative of places or data values that are going to be outliers. And so they will explicitly identify those outside of the box and whisker plot range. Versus here, it does not explicitly identify what will be your outliers according to the rule about the interquartile range. Meaning that on the low end, you want to make sure that you're doing whatever your first interquartile number is, which is Q2, that minus 1.5 times the interquartile range. And of course, for the upper end, you want to do Q3 plus 1.5 times the interquartile range. So here we have that listed. We have all of our data listed in column L1, so we're good there. And the marks that we want to use for any outliers is going to be this box here. So once we have that done, then we just hit graph. And if you notice, we have this one box that's way out here and everything else is there. So what this box and whisker plot represents is everything, all the data values that are within that interquartile range that I described earlier, and this is our outlier. To be able to figure out what all these numbers are, we will just hit trace. Okay, and so here you'll see that 29 is the last number within the data set that fits within our rules for interquartile ranges. Okay, as far as our limits to know what is an outlier and what's not an outlier. So that's what I mean by within the interquartile ranges, because we know that the definition of an interquartile range is the Q3 minus Q1. Okay, so if we trace here, we see that 15 is the minimum value of the data, but it's also an outlier because it lies outside of the first number there. And I believe I said Q2 last time, but it's really Q1. Q1 minus 1.5 times the interquartile range. So that would be an outlier there. Of course, this is smallest value that's within the range of not being considered an outlier. This is our Q1. This is our median, our middle number, our Q2. 45 is our Q3. And of course, our largest value is 56. And so you see from here, we can get all of the values that we need to sort of describe what our box plot will look like. But in addition to that, identify what all the outliers are. And thank you so much for viewing this video.